Okay, on this problem here, this is number 3. The first thing to do is break this into some different cross sections. I'm going to break it into two triangles, a rectangle, and a circle. Alright, so let's look at the triangle first. The triangle, I'm going to blow this up just a little bit. Again, it's a rough sketch. This triangle here, you want to dimension this as best you can. I believe it has a dimension of 3, and this is 15 here. Okay, so you got 2 of those, so we're going to double everything, and then we have the I'll draw another one. Let's see, we got a rectangle over here like that, and then what we have is a circle. So alright, so first thing to do is, and again I'm going to recommend this, you find everything about each one. So first thing, calculate the area, 1/2 base times height. So the area of the triangle, you got 2 of those, but the total area would be 45. Each one has an area of 22.5. That's 1/2 times 15 times 3 gives you 22.5. You double that, gives you a total area of 45 inches squared. Alright, we also know that the centroid of this one, I can do better than that. Centroid of this one is going to be somewhere in here. It's going to be up 1/3 to 15. It'll be 5 this way. It'll be in 1/3 to 3, so it'll be 1 this way. Other thing I'd recommend is go ahead and set yourself up some type of axis system here. I would set the axis system right to the middle. I think it's the best thing to do, like this, to do all your calculations. I'll change that into red so we can see that real quick. Okay, so let's get ready to go. We'll knock this thing out pretty quickly. So we have area. We have y bar. Y bar coming from here up to the center of that is going to be 15 minus 5. That's going to give me 10. We got x bar. X bar coming from the center of this. So I'm going to come over let's see, A2 I believe was 5. So we're going to come over 2.5 and then come over another inch. That'll be 3.5 here. Okay, then I would recommend the same thing. You calculate the moment inertia. Ix is going to equal to 1 over 36 times 3 being the base times 15 cubed. That would give you a value of 281.25. Now the thing is, you have 2 of these. You got 1 on each side, to go ahead and multiply those by 2. And you do that's going to give you a value of 562.5. Again, that's moment inertia about its own centroid only. Alright, scroll down a little bit. While you're here, go ahead and find let's find Iy. Iy is equal to 1 over, sorry, that looks like a 34, it's 36. 1 over 36 times the base now is 15 times 3 cubed. We run that value. I think that's going to give you 11.25. Again, double that because you have 2 of them. That gives you 22.5. Okay, go ahead and circle those in some, so you're going to remember what those are. That's Ix and that's Iy. Again, that's only about its own centroid. That's only for the triangles. Now we'll do the rectangle. The rectangle has a width, I remember right, of 5 as a height of 15. So we do the same thing, area rectangle. Again, get organized. It'll save you so many it's going to reduce headaches. It's going to save so much time. So we got 75. Okay, we know that y bar here coming straight up is going to be half of 15 or 7.5. Now the reason I put this in the middle, because that's going to let you do x bar is equal to 0. It's going to make things easier. We calculate Ix about its own centroid, and that's going to be 1 over 12 times the base times the height cubed. When we run that number, that will give us 1406.25. We run Iy, again, same thing. we're going to do 1/12, but now the 15 becomes a base. We multiply that by 5 cubed. That will give me 156.25. Again, circle those. Okay, now let's do the circle. So one thing you could do, I like to do too, is you can nail these, or mark these. You call this number 1, number 2, number 3, and this is number 4. So what this is number 1 and number 2, and this is number 3, and now we'll do number 4. And number 4 being the circle. Pi r squared would give me the area of a circle, and we make that negative because it's taking area away. Its y bar is going to be the distance up, and I think that was given as 4. B was given as 4, if I remember right there, 4. So its y bar is equal to 4, and again what saved time was we let x bar be 0 because we went right to the middle of the part. And the moment inertia about a circle, Ix in this case, and Iy will be the same thing. I think what that is, 1/4 pi, or yeah, it's 1/4 times pi times the radius to the 4th power. Again, that's going to be a negative inertia, negative 12.566. Alright, so we're ready to go. We got the inertias, we got the area here, we got the total area here, and we got the total area here. Let's do our y bar quickly. Y bar is going to equal to, we go back, we'll do the triangles first. They have an area of 45 total. So we'll calculate that real quick. That gives me 45. We'll multiply that times its y bar, which is 10, plus the rectangle, which is 75, times this y bar, which is 7.5. Minus the area of the circle, which is 4 pi, times this y bar. We keep that positive. We divide it by the total area, which will be 45 plus 75 minus 4 pi. When we do that, that gives us a value of 8.9565. Okay, again, that's the distance from this line right here up. Alright, so now let's get the moment inertias. We can do the Ix, and again, you have to do this. Moment inertia will be the moment inertia about its own centroid, each piece, plus its area, plus the distance from its centroid to the overall centroid squared. That's what we have to do each time. Alright, let me get my values where I calculated that, and we'll knock this thing out. Alright, again, I'm going to recommend you do this for each one. We'll do the triangles first. Ix of the triangles is going to equal to 562.5, which is the value we calculated right up here, 562.5 about its own centroid, plus the area, which we said was 45, and now it's to find the area, the distance is going to be 10, because that's how far it was from the bottom, minus what we calculated, 8.9565. We square that. That gives us a value of 611.50. We do Ix for the rectangle. Again, we go what we found out about its own centroid, 1406.25, plus its area. We subtract, and we said that now we went up 7.5. Again, you can do it either way. I like to make it all positive inside. So 8.9565 is the larger. We subtract the 7.5. Again, that's the distance between the two centroids. We square that. That gives me a value of 1565.3. We do Ix about the circles. And when we do that, that gives us negative 12.566. We subtract the area, and again, that's negative area, 4 pi, and we take 8.9565. That's your 8. We subtract 4. We square that. That gives us a value of minus 321. I think it's 28 or so. Again, not going to make much difference. You run the number. And that gives me a value of 1855.57. Let's see how close that is. 1855.57. And the value is 1855.6. That's pretty doggone good, huh? Alright, ready to do the IYs. Now the IYs are much, much simpler. Let's do the triangles first. Actually, let's circle this one while we're here. We'll do the triangles. When we do the triangles, again, we do the moment inertia. Oops, it's going to be 22.5. Go back up and show you where I found that. Again, let's see if we can find that. 22.5 right there. That's what we got. This IY about its own centroid plus the area of the two triangles, which will be 45. And again, if you prefer, you can do these individually. And then the distance would be 3.5 squared. Again, I have no problem if you want to do 22.5 times 3.5 squared times 2. Makes perfectly fine. That gives you 573.75. Now IY for the rectangle, you have no D because the centroids line up. And what I mean by that is this. Along this axis, there's no distance this way between the centroid of this and this line. It's a 0. Same way with the circle. That's why I like to do that. It makes things much, much easier. So when we do that, we calculated that earlier. That was 156.25. So that was about its own centroid. That stays the same. We do IY about the circle. Again, it has no distance. So what we calculate about its own. We add all that up. That gives me 717.454. Let's go check that. Right on the money. So that's our IY. Now to find IZ, all you have to do is add that one and that one together. IZ, or polar, which is equal to J, polar moment inertia, sorry. It's going to give me 2573.01. Again, I believe that's what they got. 273. Yep. Pretty doggone good. Right on there. Again, these are all inches to the fourth, inches to the fourth, inches to the fourth. Okay, I hope this helped you. Again, advice, do each one separately instead of doing some really long equation. Write down specifically what the area is, what y bar is, what x bar is, what the moment inertia in the about the x-axis is about its own centroid, and the moment inertia about y about its own centroid. And then do the problem. It's much easier if you make a mistake or something to go back and find it in here than to look through some long equation. Okay, good luck with this. You can do these problems.